All right, tonight we're going to be doing the homework for making comparative inferences about population. For number 6, it says water boils at lower temperature as elevation increases. So the higher we go, the lower the temperature is going to be of water that boils. Rob and Ann live in different cities. They both boil the same amount of water in the same size pan and repeat the experiment a number of times. Each records, the water temperature just as the water starts to boil. They use box plots to display their data. Compare the medians of the box plot. Well, the median is that line in between the box. And looking at it very quickly, we think maybe they're at the same median, but let's take a closer look. This is where 206 is. This is where 207 is. Let's count how many there is between there. 1, 2, 3, 4, 5. That tells me that there's usually a metric system there, so we're going to have about, since there's 5 spaces, each one of those spaces will be about 0.2. So let's count this out. We got 206.2, 206.4, 206.6, and 206.8. The median for Rob's temperature data is going to be at about 206.8, while Ann's temperature is at, well, let's see, 206.2, 206.4, 206.6, 206.8. As we can see, the median here is actually sitting between 206.8 and 207, which makes this about 206.9. So we can say that the median of Rob's data is going to be lower than the median of Ann's data, because Rob's data is sitting at a lower place. And it's about, well, 0.1 lower, about 0.1 lower Fahrenheit than the median of Ann's data. We can also say this means Rob is at blank elevation than Anna. We said that water boils lower and higher as the elevation increases. Since this was lower, that means he must live at a higher elevation. Number 7 says Liz is analyzing 2 data sets that compare the amount of food 2 animals eat each day for a month. Well, animal 1, we can see, eats about, as a median, 25.7, and animal 2 is sitting at about 25.8. The median of animal 2's data is blank than the median animal 1's. Well, we can say that it is greater. Liz can infer then that there is blank variability in the data for animal 1 and animal 2. Let's check that variability. We see this one starts at about 25.5 and ends at 26. As you can see, this is going to be smaller than the 25.6 that goes all the way to 26.2. This box looks a bit longer. So we can say that the variability, there is a lower variability or less variability in the data for animal 1 than there is for animal 2. Liz can infer that animal blank generally eats more food. Well, this is a pretty easy one. Animal 2 has a greater median, and its range is set at a higher poundage of food. So animal 2 generally eats more food. Number 8 says the box plot shows the height of a sample of 2 types of trees. The median height of tree blank is greater. Well, this one is no mystery. We can see that tree 1 is way greater than tree 2. Reasoning. A family is comparing home prices in town where they would like to live. The family learns that the median home price in hometown is equal to the median home price in Plainfield, and concludes that a home in hometown and Plainfield are similarly priced. But what's another statistical measure that the family might consider when deciding where to purchase their home? Well, it's great that the median is going to be the same, but remember, if we're talking about a bigger range in price, let's say in hometown, than there is in Plainfield, you might find a home that they're looking for cheaper in hometown. So the family might consider the range or the inner quartile range to determine how much the price of homes vary in each town. Here in number 10, it says the box plots show the daily average high temperature of two cities from January to December. These are the two cities, and they're showing how much the temperatures vary in the month from January to December. Which city should you live in if you want a greater variability in temperature? Let's say you like the four seasons and you don't want it to be hot all the time, and you like some fall and some winter in there. So you want a city that has greater variability. So if we're comparing these two, remember, we have to take the range, and when that's the biggest number minus the smallest number. Well, 60 minus 10 is 50, and 60 minus 10 is 50. So that doesn't tell me much. But if I look at the inner quartile range, where most of the time the temperature is going to be, I see that I got 50 minus 30, which is 20. Over here, I've got 50 minus 25, and that's going to give me 25. So the variability of city C is going to be greater. The range in temperature for each city is the same. So compare the inner quartile ranges. The inner quartile range for city X was 20, 50 minus 30, like I said. And the inner quartile range for city Y was 50 minus 25, which gives us an inner quartile range of 25. Because 25 is bigger than 20, city Y has more variability in the city. Well, I think that's it, and that was a pretty short homework assignment. I hope you enjoyed it and have a great weekend. Looking forward to seeing you next week.